Okay, so this is a step-by-step instruction video of how to analyze a rectangular truss like this. The process itself is exactly the same as a triangular simple truss that we covered in the previous class. However, the process is a little bit long because you got a lot of panels here and it could get cumbersome, so that's why I wanted to show this as a video. So I will first start by completing the force diagram, and after we complete the force diagram, then we would go over how to determine the internal force for each of these members. So first, a couple of things to note is that so we have this rectangular truss with 6 panels, and we have these loads working at each node of this truss. I mean, if you look at truss in real life, oftentimes it's supporting something like a roof, and roof, of course, would be a more like a uniformly distributed continuous loading. But in terms of, for the sake of analyzing, we are going to assume that trusses would only have a point load at these nodes. So for example, you can't really assume that there will be a load in between this node in the middle of this horizontal bar. So that would disable us from doing the analysis. So when we analyze a truss, we would always assume that there's loading only at these node points. Secondly, because this is a symmetrically loaded, it's fairly simple to conclude that the reactions would be equal, and each one of these is half of the total load that's being applied. So now we have 5 loads of 5,000 pounds, so it's 12,500 each, totaling 25,000. The force scale that we're using here is this arrow is 50 inches representing 5,000 pounds, so 1 inch equal 100 pounds. That's the force scale that we are using. So now, first step is always by labeling the zone that's between the forces. So first step is to, obviously the zone between these two forces, that's A. And if you keep naming it, it's going to be A, B, C, D, E, F, G as shown. That's between F and G, and this is between G and A. And now you're going to the inside of the truss, and you're going to name them by numbers. So that panel is 1, and you keep naming it. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way up to 12 as shown. So good. So next step is to complete the force diagram. We would want to map all of the vertical forces. So we have 1, which is, again, the length of that is 50 inches, 5,000 pound force. That's AB. We have 1, 2, 3, 4, 5 of that. So it's going to go from AB, BC, CD, DE to EF, right? Just to make sure. Right, so now these are going to be uppercase A, we have B, we have C, D, E, F. Right, so we've mapped all of the vertical force, and now we want to look at the reactions. And this is between F and G, so I would put this on here, and that would end at point G. Next reaction is going to go from G to A. starts from G and ends at G, AA. So now that we've mapped all of the vertical forces, so we're down with kind of the outside of the truss, so now we want to focus on each of these points and complete the force diagram, right? So let's start from that left side. So now we are going to look at this point. So let's just clarify that zone is 1. All of this zone outside of the truss is A, up to the force, and between this horizontal and vertical, that's A, right? So we have GA, which is this one, which was right here. So we have already mapped that. And now we will have a vertical force so let's say that's a dashed line. So this one right here is between A and 1, right? So there's going to be a vertical force that's called A1. It's going to start from point A, it's going to end at point 1. Point 1, we don't know where it is yet, so I'm just going to put it as question mark, and all we know is it's going to end up somewhere along this vertical line that passes through point A. So that's all we can tell from that vertical member. Now we are also going to look at this horizontal one, which is between 1 and G. It's going to start from point 1 and ends at point G. So what we know is it starts from point 1, so there's going to be a horizontal line which is parallel to this, right? That starts from point 1, but we don't know where the point 1 is. Another thing we know is it's going to end at point G because this is called 1G, and we know where the point G is. So now we can move this whole thing to point G. So now what we know is that point 1 is on this vertical line as well as this horizontal line. So the logical conclusion is actually point 1 is identical to point G. So that's G and 1. That means basically the force here, 1G, will not have any length. So that means the force here will be a zero force, and that is called zero force member. So in trusses, sometimes you find these cores that would have no force in them. Anyway, so A1, 1G, and GA, we've looked at all of that. So now we are ready to move on to the next point. Once we move to the next point, this is A, that zone is 1, and this zone is 2. Right, so let's look at 1A, which is going from 1 to A, so it's identical to that force. A2 is going to be horizontal, just like this one. So A2 is going to be horizontal, like this, right there. It's going to start from A, ends at point 2. But point 2, we don't know where that is yet. Then moving on to this one, right here, is between 2 and 1. So we are going to have a diagonal line, which starts from point 2, which we haven't decided where it is. But then it ends, we know that it ends at point 1 because it's 2, 1, it starts from point 2, ends at point 1. So that means it's going to have to pass through point 1, which is right here. We already know where point 1 is. So this actually allows us to locate point 2, because we knew point 2 from A2. We know that the point 2 is somewhere along this horizontal line, and we also know that point 2 is somewhere along this diagonal line. So the logical conclusion is that the point 2, the only possibility is at this intersection point. Let's clean up the diagram a little bit. So that's where point 2 is, and 2, 1 is right here. 1A, we already have 1A, so we're ready to move on to the next point. Moving on to the next point, we're gonna clarify each of these areas. That's 1, this is 3, and that's G. Okay, so looking at this one, G1 is 0, 1, 2, we already located that. 2, 3 is some kind of a vertical force parallel to that member. We know where point 2 is. Point 3 is going to be somewhere on this vertical line, but we don't know exactly where that is. So we'll leave it at that, and then we're gonna look at 3G, which is going to be horizontal like that, and G is right there. So 3G must pass through G, and it must be horizontal. So 3 is somewhere on this line as well as somewhere on this vertical line. Again, the only possibility is at the intersection, so now we can locate point 3 to be right there. Oops. Let's clean up the diagram. 3G, G1, 1, 2, 2, 3, right? So we are now ready to move on to the next point. So that's to area 2, area 3, area 4, B, and A. So if you zoom in, the vertical is AB, which we already have, which is right here. B4, there is going to be a horizontal line that passes through point B, and 4 is going to be somewhere on this line. Could be anywhere, right? And the next one, going to the next one, following this arrow clockwise, that diagonal would be called 4, 3. So now that's 4, 3 is going to pass through 3 for sure, and 4 is going to be on this diagonal somewhere, and we knew it was also on here somewhere. So again, intersection as only possibilities, which helps us lock down point 4. So 4, 3, 3, 2 is here, 2A is there. So we are done analyzing this point. Moving on to the next one. 3 is here, 4 is here, 5 is here, and G is here. Zooming in. So G3, we've located that. 3, 4, we've located that. 4, 5, which is a vertical, which we haven't located, so it's going to pass through 4. There's going to be a point 5 somewhere. 5G is going to help locate the point 5 further. So 5G is a horizontal line that ends at point G. So there's got to be a line here. So 5 is also along this horizontal line somewhere. Again, intersection between the vertical and horizontal as the only choice. So that's going to help us locate point 5 right here. Just cleaning up the diagram again. Now we're ready to move on to the next point. Alright, looking at this point, AC is already there, which is here, AC. C6 is C6, so we don't have 6 yet. So C6 is a horizontal line that passes through C and 6. We know where C is, but we don't know where 6 is yet. So 6 would be somewhere on this line, on this horizontal line, right? We also have this diagonal 6, 5, right? So we are going to, so that's going to pass through point 5, which we know is here. And 6 is also on this diagonal. So now, again, if it's on this line and on that line, the only solution is right there. So that's where point 6 will be. Five, 6, right? 6, 5. So 5, 4 is right here, and 4B is right there. So we have to move on to the next point, which is right here. So 5 is here, 6 is here, 7 is here, 8, and G. So now looking at this point, G5 is this line, so that's done. And 5, 6 is this, so we've done that. 6, 7, we haven't identified those yet. So we are going to assume that it's a vertical line and 7 to be somewhere along this vertical line. That diagonal here is 7, 8. Which should pass through 7, which we haven't located yet. So 7 is somewhere along this vertical, and we have this diagonal line. And 8 is going to be somewhere on this diagonal line. But we don't know where that is either. So we actually now have two unknowns. 7 is along this vertical, and 8 also travels along this line. So we have two moving targets now. So let's look at this horizontal, which is between 8 and G, right? So it's going to start from 8, which we don't know where, but we know where G is, which is right here. So now we are going to have a line, and 8 will be on this horizontal line somewhere, but we have too many unknowns still to lock down 8. G5, that's already taken care of, which is right here. 5, 6, we already know what it is. So this is as much information we can get from this point, so we have to move on to this next point. So 6, C, D, and 7. So zooming into this point, we have this one, which is CD, which is right here. D7 is horizontal line, which we don't have yet, so we're gonna map it by locating this horizontal line here. And 7 would be somewhere on this horizontal line. And from before, we knew that 7 was also on this vertical, so now we can lock down 7, right? So that's going to be 0.7. So that would actually enable us to lock down that diagonal line, which passes through 7 and 8. So actually that diagonal line is on here. So now we know 8 is on this diagonal line as well as on this horizontal line from before. So it's got to be at the intersection, which is actually the identical point as 0.5. So actually 0.5 is also 0.8. Just cleaning up the diagram. So that's what we get so far. All right, so we have D7, 7, 6 is located, 6C is located. So now we have to move on to the next point. We're halfway past, so it's probably easy for you to assume that the entire diagram must be because the loading and truss is symmetrical, so the entire diagram will probably end up looking like this. But however, we haven't really located the numbered points, so we're just gonna go through the entire process, but just so you know that it's probably likely that the diagram will end up looking like this. So let's confirm that suspicion. So again, looking at that point, that's G, that's zone 8, that's zone 9, that's zone 10. So zooming in, let's look at G8, which is right here, right? 8, 9. So we will have some sort of vertical line starting from point 8, which we have just located, and point 9 would be on this vertical line somewhere. Alright, so now that much we can get from there. So we also have 9, 10, which is going to be this diagonal line, right? Which is going to pass through point 9 and point 10. Neither of them we located yet. So I'm just going to assume 9, this diagonal line here, it's going to pass through 9, and 10 would be along this diagonal line again. But we don't know where it is yet. So that's what we can get from this diagonal line. So we're gonna go through to the next one, which is 10G, which has to be this horizontal line, which is gonna pass through G, which is gonna pass through 10 as well. So 10 is going to be somewhere along this horizontal line. Let's just color it because we don't know. But this one, currently 9 is also unknown, so we can't really lock them down yet. And that's all we can get from this point, so I'm going to move on to the next point to get more information. So that's zone 8, zone 7, zone D, zone E, zone 9. So zooming in, DE we've already located, which is this. E9 is going to be a horizontal line, and 9 is gonna be somewhere on this line. So we know now between 9 on this vertical and that horizontal, so only possibility is the intersection. So 9 is right there. So that would also help us locate number 10, because there's going to be this diagonal line, right? And 10 is both on this horizontal and that diagonal. So the only possibility again is at this intersection, which ends up being identical to point 3. So point 3 is also point 10. So that's 3 and 10, right? So that's gonna go away, and again just clean up the diagram. All right, so that was after we located 9. 9, 8 is right there. 8, 7 we already have. 7D we already have here. So we're ready to move on to the next point. Ten is here, 11 is here, 12 is here, G is here. Now we're gonna zoom in. G10 is already mapped here, so G10, G10, right? Moving on to the next one, 10, 11 is going to be along this vertical, and it's going to pass through 10. So 11 is going to be somewhere on here, but we don't know where, right? And so going to 11, 12 is again 11, we don't know yet. And also 12 is going to be somewhere on here, but we don't know. So 2 unknowns, right? Then going to the next one, 12G. So it's going to be through horizontal line starting from G, and 12 is going to be somewhere on this line. But we don't know where yet. So we're gonna move on to the next point. So that's zone G, zone 10, zone 9, zone E, zone F, zone 11, right? So now we do have EF, which is here. F11, that's going to help us locate 11, because it's going to start from F, it's going to be horizontal, so it's going to be on here somewhere, but we also knew that 11 was this on this vertical line somewhere. So again, the only possibility for 11 is that intersection. So now I can remove this and move this to the actual point 11. So now point 12 was either actually both on this diagonal as well as that horizontal. So the only possibility is again at the intersection, which ends up being actually identical to point G and point 1. So this is actually point G, point 1, also point 12. Alright, cleaning the diagrams. So that actually completes the diagram, but let's keep looking through all the points. So 11, 10, we've located, that's vertical. 10, 9, which is here. 9E is already located, so we are good with this point. Now we're going to go back to this point, and keep in mind F is all along this side up to the reaction, so that is zone F. Zone 12 is right here, zone G is in here. So if you zoom in again, this is FG, which is here, right? G12 is actually 0 because G and 12 is identical, so line that connects those 2 points would be length 0. 12F is right here, so it's the opposite. So now we can move on to the next point. So 12 is here, F is there, and 11 is there. Zooming in, the vertical is F12, so it would be right here, right? That diagonal is 12, 11, which is the line that connects 11 and 12. And this horizontal would be 11F, which is this. So that completes the construction of this force diagram for this truss. So next we are going to look at how to identify the internal force in each of these cores by drawing vector on top of this force diagram.